Hello everyone. So in this part we are going into multi-degree of freedom system. Before getting into multi-degree of freedom system, let's recap what we have done in single degree of freedom system. In single degree of freedom system, first we considered undamped free vibration and we see the responses and we looked at how the signal it's going to respond. Then we considered damping. So then we see damped free vibration. Then we introduced harmonic forcing. Then we studied unit step loading and its response. Then we improved it and converted into impulse loading and studied its response. Once we know the response of impulse loading, so we said by using the convolution integral we can write the response for any general loading that is possible. Then we seen that can be see done equally with use of Fourier series, where the we consider the signal is periodic with a time period t. Then we did study Fourier transform to which is the very important tool in order to convert time domain response into frequency domain response. So then we concluded with these things as single degree of freedom system. So let's get into multi degree of freedom system. So what is multi degree of freedom system? As the name suggests, to represent the system, you need more than two coordinates to define the system. So is there anything new we are going to study in this multi degree of freedom system? No. So whatever the techniques we have studied for single degree of freedom system will be same for multi degree of freedom system. So what is we are going to study? So we are going to study only about how to convert multi degree of freedom system into single degree of freedom system. So in order to do that, we need to know certain characteristics of multi degree of freedom system. So that one of those things is the coupling. So let's see how multi-degree of freedom systems are coupled. So there are three couplings exist: stiffness, mass, and damping couplings are there. Can we able to simplify this equation? Yes. How? By using some mathematical methods, mostly linear algebra. How we do that is by doing diagonalization of all the matrix in the differential equation. Once let's see what is diagonalization. Diagonalization is converting the any matrix such that all the in diagonal terms are alone non-zeros. So once it is diagonalized, so the differential equation will be on this form where you can see only diagonal elements are non-zero. Once the diagonal elements are non-zero, then the equation 1 will contains only x1, whereas equation 2 contains only x2 coordinates. So this is the beauty of diagonalization. So what here happened is we converted two degree of freedom system into two single degree of freedom system. From this we can uh, find the response of x1 and x2 so independently. The core concept is here is to convert coupled differential equation into uncoupled differential equation. Let's say you have in degree of freedom system. So we are using some mathematical methods, namely diagonalization, to convert n single degree of freedom system. This is what we are going to explore in further section. So we will consider undamped multi-degree of freedom system, then we will do diagonalization. Then we will consider damped multi-degree of freedom system. Then we do diagonalization and convert into single degree of freedom system. So how we will diagonalize for a multi-degree of freedom system is by using the eigenvectors. So let's say you have if you consider a damped multi-degree of freedom system, so we will use this